well, we're back making more progress on this sports barndominium. You guys that's been following along, we've had quite a few updates we've already done where we've shown a little bit of the progress on this particular build. This is going to be a little bit more of a challenging build for us. We had to do some work on the structural side. This is a Stacy Lynn design, so it's pretty exciting. We're doing an all-in sports barn though. It's got a full court gymnasium as well as a workout facility, state-of-the-art, something you guys definitely want to follow along on. And we're back here today working on the steel frame. Hope you guys enjoyed this video. Let's get it going. So the last time we were over here, we were actually working on our foundation, and the guys were working to do some of the finish work on that. And we usually try to give ourselves several weeks for the concrete to cure. The main reason why is when we start working on our steel frame, it takes a pretty heavy equipment for this, especially this particular project, because we got heavier steel that we're working with. So we're going to be using the SkyTrack, which it weighs a minimum of 27,000 pounds before we even start putting any load on it. We try to give it the full cure time as much as possible. Here, instead of waiting like 4 weeks, I think we were inside of 3 weeks or so, or a little bit after 3 weeks, where we started doing what we're doing. But it's quite a process just to get all your concrete done. We've got our embeds, all of our plates put in. Another detail that we do, which I'll show you right here, you can kind of see these are all our overhead doors. And this is a detail, actually I saw Steve Basic point out on somebody else's, but we've been doing this for some time. And we do a step down, which creates an inset for our garage doors, allowing the garage door to come down and to set at a lower point, so it dams any water that could come back inside. Sometimes it doesn't always work out where you can do it, but in this case, like I said, we've got it on all 4 of these openers, or all these openings. We're gonna have 4 overhead doors right here off the gymnasium. So that's a detail that we might share a little bit more later on, but just wanted to kind of point that out. So what we have here for our layout is, on this whole part of this slab is all the gymnasium. So this is all one big basketball court. It's going to go in here full. I think it's going to be more like high school regulation. So, but it's not quite as long as an NBA court, more like high school, but the width should be fine. And then another thing we did for the court itself is we've got a little bit more of a drop down between here and there than we normally do. I think it's just over 2 inches instead of our typical 1.5 inch drop down. Really the only thing that's different here that what we're doing than from our living quarters to our gymnasium on this point. All of this is conditioned space though. This could be converted to a shop if somebody wanted to use for a shop later instead of a full court basketball court. So we're kind of keeping that in mind, trying to give additional options, thinking about resale if somebody had to resell or wanted to resell a structure like this, as opposed to just having a full court gymnasium. So this could be a car collector's shop, you know, and all of this is going to be climate controlled. We've got our living space that's going to be over here, which is where the guys are working now. And we're laying out all the columns and the spanning beams across there. So that'll come to a certain point, and then it'll go to the full court basketball. But there will be a working facility, like a gym workout area, that's going to be here with a sauna and all kinds of stuff, cold plunge. So a lot of cool stuff happening here on this part, with the full living quarters up above and a walkout balcony that's going to be on the far end. So that's kind of the precursor to all this. Kind of gives you a little bit of what's to come on this build. Yeah, so we're having to play around with the chains a little bit because this is a single slope Barndominium, bigger steel than usual, so we got a little bit different techniques that we're having to use to adjust to the slope, because that way when we pick it up, we're not putting all the weight just on one chain. We do want it to kind of sit slanted slightly, or we got to grab it from one point, but we're trying to grab it from 2 points because for safety reasons. So it'll take us a minute, but we're just trying to adjust it. Once we do it on this one, we'll do it the same way on everything. All right, we got it tweaked in. I think this is going to work good. We've got chains and straps just to cover our bases. And we're about to start setting this one on that end area. We adjusted the slope. Fingers crossed, everything's going to go good, because we got to do this 1, 2, 3, 4, 5, 6, 7 times. Seven times. Right now our objective is he's going to set this in and rest it on top of our already pre-cut vertical columns, and once we get it positioned exactly where we want it, then they'll start tacking and welding all this off. That way it'll all be secured. When we get this one up good, we'll keep the bracing on it, then we'll have something we'll be able to tie the next pieces to, and as we go down the line. So every piece of steel that we add, it'll make our structure just a little bit stronger each time.
Well, we got it up here. Looks like first one set went actually pretty smooth. Had to reset the chains a couple times to get the heights right, but that was pretty much dead on for our slope we were looking for. I mean, we were within a couple inches pretty much of the post there on the low side. So right now you can kind of see the guys, he's got his level there, and he's got that, it's an old chain binder basically that we modified. And what he's doing with that is he's tacked it to the leg and to the rafter, and he's pulling it into plumb basically with the leg where he wants it. And he's got that clamp there as well, and that clamp's just a brace that he's using to, one, create some leverage to kind of manipulate the leg a little bit, and two, kind of hold everything where he's wanting it so he can tack it in place and get everything squared up.
So when we started construction on this project, one thing that was for sure is we already had an existing structure here. It was approximately, I want to say 35 by 60, somewhere in that range of a structure. And it, I believe, had 16-foot eave walls, but you guys, we tore this whole structure down. We showed that already in previous videos, but here's the thing. When we got into excavating the foundation of that building and that structure, we also had to adjust our whole level plane. We ended up putting this slab at a similar level that the other slab was, but in order to do that, we had to cut into some of the back areas, which means that we had huge rock that we got into. You can see these boulders right here that I'm standing on. This is just some of the rock that we pulled out. They actually had to haul a whole lot of this off, but you know, we needed to build up around these areas anyway, so we're using these more for retaining. But it's pretty crazy when you think about it. But like, yeah, we were pulling these huge boulders out of the ground so that we could make way for more rock, which is our concrete. But turning the structure this way actually turned out to be a lot better, because initially they wanted to turn it the other way. And we had some challenges with that because we had power lines that run across the middle here. Now we're actually getting those lines rerouted. They're going to go around this structure so that they can have their full yard space in the front. So those are some other things that we did logistic wise on this property for some of the easement and the power lines that came straight through the middle of the property, which is a little unusual anyhow. So that just kind of shows you some of the challenges that we had as we got started. It was quite a process, but we worked with a local contractor who was able to have all the equipment here on site and be able to use a braking hammer with excavators as well as a dozer to completely get rid of all the flat work and the concrete that was here. So there's a lot more flat work that's going to go in when it's all said and done, but as it is right now, we're just focusing on our structures.
So on this project here, we consulted with an engineer for some of our beam sizing, placement, some of those details here. Typically on our metal buildings here, we use a lot of like 8-inch by 10 pound per foot, 12 by 19 I-beams, and then we'll use like some 4-inch square tubing of like 1/4 inch or 3/8 thick, depending on our eave heights and our beam spacing and some of those details there for kind of your typical metal buildings that we build. On this structure, due to the size of it, the spans we were going, and just the weight load considerations, we actually needed a lot larger steel here on this one. For our legs on this one, we're using a 12-inch by 40 pound per foot I-beam here. And some of the differences on this, like the flange here is actually about 8 inches wide, where a typical I-beam is 4. So you have a little more space taken up in your wall cavity when you're framing, when you're considering, you know, your coverage of your, whatever your wall surface you're going to cover these in. You know, so there's some kind of different considerations you got to make there. And also the thickness of this is about a 1/2 inch thick flange, where typical I-beam is a little bit thinner, maybe 1/4 inch, you know, somewhere in that range.
So most of the time when we're doing a structure like this, there are occasions where we will add vertical columns by themselves before we put the top pieces on there. We do this sometimes when we might not have the lifting capabilities like we do out here today, with say maybe a skid steer where we're working with smaller profiles. But in this case, the only reason we're doing that is because we have such a tall structure. We didn't want to be lifting up the whole structure and putting all the pressure all at once, because just one spanning beam that goes on the top weighs several thousand pounds. So that's one reason. The other reason is we're not standing them up ahead of time, because as we're lifting these main I-beams that sit on top, we don't want to be having to maneuver around all of these wall pieces that are standing up, because they're going a little bit past the I-beam. So that's some of the reason why we're doing it this way. It takes a little bit more time because you're kind of shifting your direction each time. But once we get past the living quarters, we'll have a little bit wider spacing, and we may see if we can shift it up a little bit. So that's what's happening right now. So our typical steel is like 12 inches and weighs 19 pounds per foot. And I know Brandon is the one who normally orders this steel, but we did some special things on this. We worked with the engineering to get our sizing appropriate. This is a 24-inch, 68 pounds per foot. That's the thickness. As you can see, this is a lot bigger steel that we're using here to span across from one side to the other. And technically I can span a beam like this anywhere from 60 to 70 foot. Now on this particular span, we're going about 56 foot from one side to the other. So we're well within our reach on this. So now mix that with spacing and being conservative on your spans. Gives you a lot of flexibility for all of the upper areas that you're trying to accomplish. So that's something to keep in mind when it comes to steel spans and what we're accomplishing with that. So if we were going to try to use something different other than steel to do this, it'd have to be like a glue lam structure or some other type of an engineered wood product that you could run across from one side to the other, but it's just too far to span for use. At least you could, but it would have to be very large beams, way bigger than 2 foot, I can assure you of that, to get a wood beam that goes across there. So that's the reason why we use steel. There's a lot of other things that are going to be a little bit different on this build that we're going to share throughout the steel framing, so you guys have to follow along for more on this, because we got some different details on this build. So a lot of good things that are going to cover a larger territory of conversation. So hope you guys will join us along as we discuss all that later on our steel framing. Okay, well, this is pretty much going to conclude our progress for the first day, really, of lifting up steel out here. The guys were out here doing some measurement and doing a little bit of preparation yesterday, but we're just kind of getting acclimated to the process of what we're going to be doing here. Like I said, nothing new for these guys. We have a really great team, and you guys have seen all the stuff that we fabricated before in the past. But this is going to be one heck of a project. So we got a lot of progress to go, a lot more work to go. We're probably about 40% on just the main frame for the I-beams. So once you get your I-beams, we're going to be adding purlins across the roof lines. We've got our wall girts that we'll be installing. And one thing that's a little bit different here is the way we're doing our gymnasium area, where we'll have the full court basketball arena. That space is going to be all steel purlins there on the walls. So that's a little different than what you guys have seen us do. Although in like fashion, we will be adding the zip system. So that'll be going over the top of the whole thing. So some really special details we're gonna be covering on this build. Hope you guys have enjoyed this video. I'm Josh Helm, wishing you all the best. Thanks for watching. Texas Best.